Good morning, class. We are looking at chapter 7, trigonometric identities and equations, also known as analytic trigonometry. 7.2, sum and difference formulas. So we've looked at trigonometric equations, identities, now sum and difference formulas. We're going to move on to double angle, half angle, product to sum, sum to product, and solving trigonometric equations. The objectives are use sum and difference formulas to find exact values, to establish identities, to formulate formulas involving inverse trig functions, and solve trigonometric equations linear in sine and cosine. Reminding you of the importance of fundamental identities that we have learned. Again, a point having coordinates x and y. X represents cosine and y represents sine. This is a unit circle. Fundamental identities, such as Pythagorean identities, sine squared plus cosine squared equals 1, and so on. Quotient identities, tan theta is sine over cosine, and so on. Reciprocal identities, cosecant is 1 over sine, and so on. Even and odd properties. Even means f of minus x is f of x. Odd means f of minus x is minus f of x. As it was mentioned before, all trigonometric functions are odd except cosine and therefore secant. A periodic function repeats its values at regular intervals, and trigonometric functions that are all periodic. K as an integer. 2 pi is the period for all of them except tangent is pi, and with that goes cotangent. Here's the summary of sum and difference formula, section 7.2. Sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. Tan of alpha plus beta is tan alpha plus tan beta over 1 minus tan alpha tan beta. And tan of alpha minus beta is tan of alpha minus tan beta over 1 plus tan alpha tan beta. That's the summary of this section. These are new formulas, and more formulas are coming your way. You should be very comfortable with those. And now let's elaborate and look at the proof. So we are starting with cosine, and to understand that, we start with two angles, alpha and beta. So alpha is the bigger one, and therefore this point P sub 2 has coordinates x is cosine alpha, y is sine alpha. Beta is the smaller angle, and therefore P sub 1 has coordinates cosine beta, which is x, sine beta, which is 1. If we set up an angle here such that this is the difference of alpha and beta, so this angle is alpha minus beta. Of course, this one has coordinates 1, 0. The coordinates for this one, x is cosine of alpha minus beta, and y is sine of alpha minus beta. And these two distances, because they cover the same central angle, they are the same. So the distance from point A to P3, from point A to P3, this distance, is the same distance from P1 to P2 because it covers the same angle. So we go with the distance formula. Distance is x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And you can square it both sides to deal with the distance squared. So for here, we get this one. Cosine of alpha minus cosine of beta quantity squared plus sine of alpha minus sine of beta quantity squared according to the distance formula. For the green one, cosine of alpha minus beta minus 1 because the x coordinate is 1 quantity squared, and then sine of alpha minus beta minus 0 quantity squared. And as I mentioned, the two are identical. So what we are going to look at, we are going to look at the two without the square root. So this one without the square root, this one without the square root. Why is that? Because it's easier to work with. And you know all these identities. So this one, cosine squared minus 2 cosine alpha cosine beta plus cosine squared of beta. This one, sine squared minus 2 sine alpha sine beta plus sine squared of beta. So that one is the left-hand side. This one, cosine squared of this angle, meaning cosine squared of alpha minus beta, minus 2 times the first times the last, minus 2 cosine of alpha minus beta, plus 1, because when you square this, plus 1. This one, this has no bearing, so it's just sine of alpha minus beta squared. Let's take a look at a bunch of stuff. These two add up to 1. These two add up to 1. So we have 2. So we have cosine squared plus sine squared of alpha minus a 2. We are going to factor the negative 2 out from this 2. This. We get cosine alpha cosine beta plus sine alpha sine beta. So we have this one, we have this one. And the right side, this one, and this one, cosine squared plus sine squared. We have the same arc or angle, alpha minus beta. So we put those two together, and this one, minus 2 cosine of alpha minus beta is remains, and plus 1 remains. So what do we have now? Let me erase my work. So on the left side, we have a 1 here. We have 1 here. So we have a 2 minus 2 times cosine alpha cosine beta plus sine alpha sine beta. On the right side, we have 1 here, 2, and then negative 2 cosine of alpha minus beta. So again, just to make sure we understand what's going on, everybody. On the left side, we have 2 and this piece. On the right side, we have a 2 and this piece. So very straightforward. what happens? Well, let me erase it. The 2's cancel out. We end up with negative 2 times this, negative 2 times that. We can cross out the negative 2 as well. So we are going to write this equals this. And take a look. What is this one? This is cosine of alpha minus beta. We proved that cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. We proved that, and that's what we've been looking for to prove. So pretty straightforward, everybody. All right, so we're done with this part. How do you prove that? All you have to do, cosine of alpha minus, replace the beta with negative beta. So cosine of alpha plus beta is cosine of alpha minus negative beta. The reason we are going to use that because we know the result for this. So cosine of alpha minus, let's say it's gamma. So anywhere you see beta, change it to gamma or minus beta. So replace the beta with minus beta in here. So we're going to write cosine alpha, cosine of minus beta, plus sine alpha, sine of minus beta. As you know, cosine is an even function. So cosine of minus beta and cosine of beta are the same. However, sine is an odd function. Sine of minus beta is minus sine beta. So this is the same as cosine beta, doesn't change. But this one is minus sine beta. And therefore, cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta, which is the first one. So that's the proof. Now, example one, use sum and difference formulas to find exact values. We want exact values. We don't want any calculators. Cosine of 7 power 12. And if it's hard for you to see what you need to add, you can bring them to degrees. It makes it easier to see. But I hope you know by now that this is obviously 3 power 12 plus 4 power over 12. 3 power 12 is power 4. 4 power 12 is power 3, both of which are common arcs. That's the idea. One thing that may be helpful, remember class, pi over 6 is 30 degrees. So remember pi over 12 is 15 degrees. So that might be helpful. All right. So cosine of alpha plus beta, we are going to use cosine of alpha plus beta. So cosine alpha, cosine beta, cosine of power 4, cosine of power 3, minus sine alpha, sine beta, minus sine of power 4, sine of power 3. Cosine of power 4 and sine of power 4, we know both of them are square root of 2 over 2. Cosine of power 3 is 1/2. Sine of power 3 is square root of 3 over 2. Again, these are all common arcs. We should know them. So both sides, both of them have the same denominator 4. This one is square root of 2. This is minus square root of 6. So we're just adding two fractions. We want to go through the same process, and we want to find the exact value for cosine of 15 degrees. We should easily recognize this as cosine of 45 minus 30. And we're going to go with cosine of alpha minus beta. So cosine 45, cosine 30 plus sine 45, sine 30. Again, common arcs, all of them, this and this, both of them are square root of 2 over 2. Cosine of 30, square root of 3 over 2. Sine is 1/2. Again, they have the same denominator, both of them 4. This one is square root of 6, this one is square root of 2. So we get square root of 6 plus square root of 2 divided by 4. And again, as I mentioned, pi over 12 is 15 degrees. Okay, everybody? So that might be helpful to deal with that when it's in radian mode. Well, we proved for cosine. Now we're going to prove for sine. So sum and difference formulas for the sine functions. We want to prove sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. And sine of alpha minus beta is the same thing for the negative sign in between. So let's see how that works. Cosine of power 2 minus theta equals sine of theta. Sine of power 2 minus theta is cosine theta. Those are co-functions. Okay, remember cosine and sine are co-functions. If the two angles, this one and this one, add up to power 2, sine of one becomes cosine of the other. Tan of one becomes cotangent of the other. Okay, co-functions. So if we graph him, we're going to go over the proof of that again. If we graph these two, one of them is cosine of power 2 minus x, one of them is sine x, it just gives you one graph. So observe that no matter what, it doesn't give you two. And that's from a calculated point of view. However, let's look at this one, cosine of alpha minus beta. Let's follow this. So cosine of, we're going to call it number 1. Cosine of power 2 minus theta, according to this, is cosine of power 2 cosine theta plus sine power 2 sine theta. And everybody knows that cosine of power 2 is 0, sine of power 2 is 1. So this goes to 0, right? Because they're product, and this is sine theta. So we just proved, number 1, that cosine of power 2 minus theta equals sine theta. Again, we had discussed that before. We showed it with the concept of a co-function. But in any event, now we have proved it using calculators and more importantly, cosine of alpha minus beta. So we proved that. So that one is proved. To prove this one, we are going to rewrite cosine theta in the following manner. First of all, please understand what's happening here. We are saying cosine theta equals cosine theta because in here you have pi over 2. Now distribute. You have minus pi over 2 and you have plus theta equals theta. So we are saying cosine theta equals cosine theta. But we are writing the theta such that this pi over 2 is there. So we're going to write pi over 2 minus, then this sum parentheses. That parentheses, we call it whatever we want. Let's say x. So it's pi over 2 minus x. Okay. So if we go back to this formula, cosine of pi over 2 minus theta is sine theta. So cosine of pi over 2 minus x must be sine x. I hope everybody's following that one more time. We are saying this is cosine of pi over 2 minus x. Because cosine of pi over 2 minus theta is sine theta, cosine of pi over 2 minus x must be sine x, which is, now what is x? Pi over 2 minus theta. Replace the x with pi over 2 minus theta. Sine of pi over 2 minus theta. So in essence, we are proving cosine theta is sine of pi over 2 minus theta. So let's just write cosine theta. Okay, we're just putting it here. And this box, call it number 2. This is the same as number 2. Believe it or not, we proved this with the algebraic manipulation of theta being pi over 2 minus pi over 2 plus theta. That's it. So we proved number 1, cosine of pi over 2 minus theta is sine theta. Number 2, sine of pi over 2 minus theta is cosine. Now, this is from the previous page. And we have this. So if we are looking at sine of alpha plus beta, I want you to look at this one. Sine of theta. Imagine this is theta. So it would be pi over 2 minus theta. That means pi over 2 minus alpha plus beta. Again, I want you to look at this one, everybody. You're looking at the proof. You look at this one. We are saying sine of theta. Sine of theta is cosine of pi over 2 minus theta. Cosine of pi over 2 minus theta. Theta happen to be alpha. So we let theta be alpha plus beta. That's all we're doing. It's a very straightforward, everybody. Now we are going to expand. So we are going to expand this one because we know cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. So this would be writing pi over 2 minus alpha minus beta. We are going to rewrite this as pi over 2 minus alpha minus beta. Please understand this is minus alpha minus beta. When we distribute that, we keep these two together. Okay. Now, let's follow that. So cosine of this, that means cosine of power 2 minus alpha, times cosine of this cosine beta, that's this part, plus sine of this, sine of power 2 minus alpha, sine beta, according to this formula. Why are we writing it in this format? Because we know cosine of power 2 minus alpha is sine alpha. So this is sine alpha. I need a different color. Let's see. And this one makes this one cosine. Sine alpha cosine beta plus cosine alpha sine beta. Believe it or not, we proved sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. That's all. And now sine of alpha minus beta, we are going to write it sine of alpha plus minus beta. So we are replacing with minus beta into this formula. We are replacing this with negative beta. So if I'm replacing this with negative beta, I'm replacing the same thing on the right side, beta with negative beta. So this becomes sine of alpha cosine of minus beta plus cosine alpha sine of minus beta. And as you know, again, cosine is even, sine is odd, which means this is the same as cosine. Because this is the same as negative sine. Therefore, the answer is sine alpha cosine beta minus cosine alpha sine beta, and that's the proof for sine of alpha minus beta. Now, let's find the exact value of sine of 19 pi over 12 using the same methodology that we did for cosine, use the sum and difference formulas. And we want to come up with the exact answer. Now, 19 pi over 12 is 16 pi over 12 plus 3 pi over 12. This is 4 pi over 3, this is pi over 4, both of which are common arcs. So sine of alpha plus beta. Sine of 4 pi over 3 cosine of pi over 4 plus cosine of 4 pi over 3 sine of pi over 4. Now, pi over 4 common arc, 4 pi over 3 common arc, and I'm going to remind you of reference arc again. So 4 pi over 3, the reference arc is pi over 3. What it means is that sine and cosine for this one also have the same value. You just have to figure out whether positive or negative. So think about pi over 3. So it's the same as sine of pi over 3, which is square root of 3 over 2. However, this is quadrant 2, quadrant 3. In quadrant 3, sine is negative. So power 3, sine of power 3, square root of 3 over 2, quadrant 3 makes it negative. This is square root of 2 over 2, this square root of 2 over 2. Cosine is also negative. In the third quadrant, both sine and cosine are negative. So power 3, cosine is 1/2. Cosine of 4 power 3 is negative 1/2. So that has got to do with understanding the reference arc and the quadrant 3. Okay. So again, the denominator in both cases is 4. That's fine. This gives us minus square root of 6. This gives us minus square root of 2. You can write it in this fashion, or you can put a negative in front of a fraction bar and make both of them positive. It's, in other words, and you don't have to, it's just if you see it in this format, minus square root of 6 plus square root of 2 over 4, that's the same thing. Okay, it depends on how you approach it. That's the same thing. Pretty straightforward. Use sum and difference formulas to find the exact values. Cosine of 40, cosine of 80 minus sine of 40, sine 80. So this looks like what? Take a look at cosine of alpha plus beta. Again, you have to memorize these formulas, but for now. So it looks like cosine of alpha plus beta. So it's cosine of 40 plus 80, which is 120 degrees. Again, let's discuss the reference arc. So this, the reference arc, 60 degrees. You can say 180 minus 120, that gives you 60 degrees. So it's the same value as cosine of 60 degrees. However, in quadrant 2, cosine is negative. So cosine of 60 degrees is 1/2, but for 120 degrees becomes negative. That's all. Oh, pretty straightforward. What happens here? Sine alpha cosine beta minus cosine alpha sine beta. Think about it. So that means sine of alpha minus beta. That means sine of 80 minus 20. That means sine of 60. That means square root of 3 over 2. So that's very straightforward, everybody. I hope everybody's okay with that. All right, we are going to move on. Square root of 3 over 2. We should be comfortable with common arcs and their trigonometric values. Finding exact values, given sine of alpha is 4 over 5 and alpha is between pi over 2 and pi. quadrant 2, and sine beta is negative 2 over square root of 5, or rationalize it to negative 2 square root of 5 over 5 between pi and 3 pi over 2. This is quadrant 3. Okay. We want to find the exact answer for cosine alpha, cosine beta, cosine of alpha plus beta, sine of alpha plus beta. By the way, even if they don't ask for A and B, part C and D require that we get those. All right. And you can get from, for example, sine alpha to cosine alpha using circles or identities or both. You don't have to do both, but you need to understand how they work. So, for example, sine of alpha is 4 over 5, and the formula is y over r, and alpha is between pi over 2 and pi. This is given, everybody. Everything that I'm writing is given. The only thing I'm reminding you is that it's y over r. So y must be 4. If you go with the circle, r must be 5. And so basically we are saying that 4 squared plus something squared, that means x squared. X squared and 4 squared must be 5 squared. That's what we are saying. So y is 4, r is 5, and it's in quadrant 2, Q2, quadrant 2, quadrant 2. So x squared and y squared is 25. So this has coordinates x comma 4. And the fact is the quadrant 2, clearly x must become negative. So you can see if you plug in, you get x squared equals 9 and x equals minus 3. I'm assuming we can do this. So let's just write down if I have enough room here. X squared plus 16 equals 25. X squared becomes 9. X is plus minus 3 and negative 3 because of the quadrant. Okay. Because of the quadrant. So cosine is x over r minus 3 over 5. We're done. However, just to remind you, remember sine squared plus cosine squared is 1. And with that comes cosine of alpha equals plus minus the square root of 1 minus sine squared. So I hope you remember those fundamental identities and how to go from one format to the next. So you just plug in, replace the sine with 4 over 5. When you square that, you get 1 minus 16 over 25, which is 9 over 25, and plus minus 3 over 5. And because it's quadrant 2, you decide to go with negative. I can't emphasize this enough, everybody. This is extremely important. Okay. So we have sine alpha, we have cosine alpha, we have sine beta, we need cosine beta as well. And again, we can go with one of those formats. It's up to you. So sine is negative 2 square root of 5 over 5. And it's in the third quadrant, everybody. Okay. In the third quadrant, remember, everything is negative except tangent and therefore cotangent. Okay. So if we go with the cosine being plus minus the square root of 1 minus sine squared, and you plug in, and you get, so 1 minus, this one is 2, 4 over 5. So you get 1 over 5. So 1 over 5, that means plus minus 1 over square root of 5. That's the meaning of it when you take it out. And why is it negative? Third quadrant, Sine is negative, cosine is negative, secant is negative, cosine, everything is negative except tangent and cotangent. Now we are ready to move on. So we have sine alpha cosine alpha, sine beta, cosine beta. We found those four, and now we're going to go with the formula for cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. So use this plugin. That's why I put it in a table so it makes it easy instead of looking for it here and here. This table is a nice summary plugin. So we have a positive. The denominator is 25, everybody. So negative times negative is positive. 3 squared of 5. Negative times negative is positive. 8 squared of 5. The numerator is 11 squared of 5. The bottom is 5 times 5. And you're done with this part. Sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. And use the summary that we put here. Plug in. So let's see what we get here. We get minus 4 squared of 5 here. We get plus 6 squared of 5. They add up to 2 squared of 5. And the denominator is the same 25 that we had in the previous. Now we are done. So very straightforward, everybody. A quick recap. We are given sine of some angle, okay, and sine of another angle. We want to find their cosine, and we want to find the sine and cosine of their sum. That means we need sine and cosine for each single angle. For sine alpha, we need also cosine alpha. For sine beta, we need cosine beta. We found it. I used two methods for the first one. I don't want to use the same thing here. The point of this method was to remind you, you can do two ways. I use the identity here and summarize them here. Cosine of alpha plus beta, sine of alpha plus beta, we can use the sum formula. All right. Cosine of power 2 plus theta is minus sine theta. We start with the more complicated side, which is the left-hand side. And we expand using cosine of alpha plus beta. So cosine alpha, cosine beta, cosine of power 2 cosine theta, minus sine alpha sine beta, minus sine power 2 sine theta. Replace the cosine power 2 with 0 and sine power 2 with 1. This goes away, and this becomes minus sine theta, which is the proof because it's the right-hand side. Cosine of pi plus theta is minus cosine theta. Again, we start with the left-hand side. LHS, again, I think I want to remind you when I write this, means left hand side versus RHS, okay? So left-hand side. And we're going to expand just the way we did with part A. Cosine pi cosine theta minus sine pi sine theta. Everybody knows cosine pi is -1 and sine pi is 0. So this goes away and this becomes negative, minus cosine theta. Pretty straightforward. What about tangent? Tan of alpha plus beta is tan of alpha plus tan beta over 1 minus tan of alpha tan beta, and tan of alpha minus beta is the same thing. You change those signs. Notice for this one, you change this sign to negative, this sign to positive. That's for the sake of, memorization, I'm telling you. So how do we prove one of them? Let's say we're going to prove this one, and tangent is sine over cosine. So tan of alpha plus beta is sine of alpha plus beta over cosine of alpha plus beta. So just write down this side of sine of alpha plus beta over this side of cosine of alpha plus beta. So again, I want to make sure we understand. We are going to write this in the numerator. This in the denominator. Notice this one is 1. How do you make this one 1? Divide by itself. If you divide by cosine alpha, cosine beta, everything, this becomes 1. So let's divide every term by that. So make up 2 fractions in the numerator, 2 fractions in the denominator. So what happens? These two cancel each other. Sin alpha over cosine alpha is tan alpha. These two cancel each other. Plus sine beta over cosine beta is tan beta. These cancel each other, they get 1. This is tangent alpha. This is tangent beta. Believe it or not, that's the proof. Now, just the way we did it for sine of alpha minus beta or cosine of alpha plus beta, that we replace the beta with minus. I'm going to leave it for you to show that this one works. All you have to do into this formula, replace the beta with minus beta. I'm going to leave it for you to prove that it's a good practice for you. If you change the beta to minus beta, you get this one. Just change this one. Becomes tan of minus beta. And this one, the same thing. And remember, tangent is an odd function. You could easily see the proof of tan of alpha minus beta. Tan of 2 pi minus theta is minus tan theta. We start with the left-hand side. And we are going to follow tan of alpha minus beta, which becomes tan of 2 pi minus tan of theta over 1 plus tan of 2 pi tan of theta, according to the formula here. Tan of 2 pi is 0. Replace it. So this becomes negative tangent theta, and this becomes 1. So minus tan theta, and that's the proof. Cosine of alpha minus beta over sine of alpha sine of beta is cotangent alpha cotangent beta plus 1. You start from one side. Let's start with the left-hand side. Now, cosine of alpha minus beta will be expanding to cosine alpha cosine beta plus sine alpha sine beta. Don't do anything to the denominator. Now make up two fractions. This one and this one. Now notice this, they are identical. So replace it with 1. The top and the bottom are identical. 1. This one, cosine alpha over sine alpha is cotangent alpha. This one, cosine beta over sine beta is cotangent beta. And that's the proof, and you're done. Pretty straightforward. Tan of theta plus power 2 is negative cotangent theta. Let's prove it, starting with the more complicated side, namely the left-hand side. And let's expand. We have two choices. We can expand it and get to the answer. But when we expand, we get to tangent, or write as sine over cosine. Now, if we expand, a lot of them go away. Since power 2 is a common arc, we can figure it out. So we have sine theta cosine power 2 plus cosine theta cosine power 2. The bottom is cosine theta cosine power 2 minus sine theta sine power 2. So this is the expansion from sine of alpha plus beta and cosine of alpha plus beta. Cosine of power 2 is 0. Sine of power 2 is 1. Replace. So this is times 0. So obviously this is 0, this is 0. So you get cosine theta in the numerator, negative sine in the denominator. And that's negative cotangent theta. And that's the proof, everybody. Cosine of alpha plus beta over cosine of alpha minus beta is 1 minus tan alpha tan beta over 1 plus tan alpha tan beta. And I've mentioned it before. Well, you could always do the cross product, but it's better to start from one side. In this case, let's say we start with the left-hand side. Everybody. Now you expand according to cosine of alpha plus beta and cosine of alpha minus beta. In other words, put this one at top, this one at the bottom, right? Now go back to what you want to establish. You want to establish 1 here, so just divide everything by this piece. Okay, everybody? Look at what you establish. We divide everything by it. And obviously, this is 1, this is 1. So that's not a problem. The other ones, just separate them so you can see what's going on. So those are 1. Sine over cosine, tan of alpha. Sine over cosine, tan of beta. Same thing for the bottom. So we get 1 minus tan alpha, tan beta, over 1 plus tan alpha, tan beta, the right-hand side. Very straightforward, everybody. Inverse trigonometric functions, cosine inverse of 2/3 plus sine inverse of negative 3/4. As you recall, cosine inverse represents an arc or angle. Therefore, if you call this alpha and if you call this beta, you're looking at cosine of alpha plus beta, which means you have to expand this. So you need sine and cosine. So first of all, let's look at this one. Cosine of alpha equals 2/3. That's the meaning of this class. So cosine inverse of 2/3 is alpha. That means cosine of alpha is 2/3. And remember, the restriction we put was from 0 to pi. Because it's positive, then it puts us in the first quadrant. This one, sine inverse of negative 3/4 is beta. That means the sine of beta must be negative 3/4. And because of the restriction we put on sine inverse is in the fourth, from minus power 2 to power 2 in the fourth and first quadrant. Because it's negative, has to be in the fourth quadrant. In other words, I want to make sure we know that this is quadrant 1. This is quadrant 4. We should know that. That will help us find the other ones. Now, whether I use the circles or identities makes no difference. Let's go with the identity. Sine squared plus cosine squared equals 1. We have cosine. So sine is plus minus the square root of 1 minus cosine squared. And as we said, because it's the first quadrant, everything is positive. So we pick the positive, right? And this is four over 9. 1 minus it makes it 5 over 9. So square root of 5 over 3. That's good. So we have cosine of alpha and sine of alpha. We have sine beta. We need to find sine cosine beta as well. Again, sine squared and cosine squared. And again, this formula. Now, we are in the fourth quadrant. In the fourth quadrant, cosine is positive. So we choose the positive one. Do the math. And that is 9 over 16. 1 minus that is 7 over 16. And 16 comes out, we have square root of 7 over 4. Let's find cosine of alpha plus beta. We need this summary again. Again, you don't have to write this summary, but I like to write sine alpha, sine beta, cosine beta. A couple of them were given, a couple of them we found. Plug in. So obviously the denominator is 12, 3 times 4 in both cases. So let's see what we have here. We have 2 squared of 7. And we have minus minus plus 3 squared of 5. And they add up over 12. And that's the exact answer, everybody.